Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we are going to discuss about morphological transformations in OpenCV. So we will discuss different morphological operations like erosion, dilation, opening and closing methods, etc. But first of all, what are morphological transformations? So morphological transformations are some simple operations based on the image shape. Now morphological transformation is normally performed on a binary image, and when we perform morphological transformation, there are two things which are required. First is the original image, and second is called a structuring element or a kernel, which decides the nature of the operation. Now there are different type of morphological transformations and we are going to see them one by one. Now to start with, I have this simple code which reads the image using OpenCV IamRead method, and we are just loading or showing this image using matplotlib. Now, if you are unfamiliar with matplotlib and how to use matplotlib to show images, in the last video I have explained this topic in details. So if you want to see that video about matplotlib, you can see it, and this is the code I have used in the last video also, and I have explained this code in details in the last video. So if you are confused what this code is doing, just see the last video. Now there is one important thing to notice here is I am reading this image in a grayscale mode. Okay, so either you can provide here as the second argument of IamRead cv2.IamRead underscore grayscale, or you can provide simply 0 here in order to read this image in grayscale. So let's run this code and let's see what it does. So as expected, it's just opening the image in the grayscale mode using matplotlib. Now, as I said, normally we perform the morphological transformations on the binary images. So that's why we need to provide a mask to our image using the simple thresholding. So let's just do that. So I'm going to just write underscore comma the mask. So I'm going to name my variable as mask here, and then I'm going to just write cv2 dot threshold, and this threshold take few argument, as you might already guess. First is the image itself, second argument is the value of the threshold. So for now I'm going to just provide the threshold of 220 here. The maximum value of threshold will be 255. Then the next argument here is the type of the threshold. So we are going to provide cv2 dot thresh binary inverse. So this is our mask. So let's load the mask in the matplotlib window. So I'm going to just provide in this titles array one more title, which is mask, and then we are going to see how this image looks like after the mask. Okay, and here the range I'm going to increase it to 2 because now the array is of 2 elements, and the subplot is also, let's say, 1 by 2. So we want to show 2 images, and I'm going to just run this code, and you can see this was the image, which was the grayscale image, and the second image is the masked image. Now if you see this image carefully, let me just increase the size of this image, and if you see this image carefully, after masking there are some black dots here on the balls, and let's say we want to remove these dots which are there in between this white area, this black dot or this black dot, or you can see some black dots are there inside your ball in the white area, and we want to remove these dots from the balls. For this, we are going to use the dilation transformation. So first of all, what we are going to do is we are going to just write dilation, which will be our variable name, and then we are going to use this method called cv2.dilate. Okay, so this method uses the source, which is mask in our case, and then the second thing is the kernel. Okay, so let me explain what the kernel is. So a kernel is normally a square or some shape which we want to apply on the image. So we are going to define a kernel of numpy once, which means we want to apply white square on our balls. So you can see when we run our code, once again it shows us error because this kernel is undefined. So let me define this kernel first of all. So I'm going to just say kernel is equal to np dot once, and then we are going to define the shape of this kernel. Let's say this is of 2,2 size, and then we will just say np dot uint 8. So this is our kernel, and kernel in this case is nothing but a 2 by 2 square shape, and this square shape kernel is going to be applied on our image wherever these black dots are there. So now we have defined this kernel. So let's see after this kernel is applied on our masked image how it looks like. So I'm going to just add one more title here, which is dilation, and then I'm going to add the image after the dilation is applied on our image, and then we are just going to increase the range to 3 because now we have 3 images, and let's say this plot contains images 1 by 3, so 1 row and 3 columns, right? So I'm going to just run this code once again, and now you can see all these 3 images. First was the original image, second is the masked image, and the third one is the image which we got after we applied the dilation. Let me just increase the size of this image somehow. So now you can see that, for example, here there was a black dot and now it's reduced, right? The size of this black dot is reduced. Here also there was a black dot, but its size also is reduced, but still we can see these black dots here, right? So how we can remove these black dots completely? So there is a third parameter which we can provide to this dilate method, and it's called iterations. So number of iterations. So we can just provide iterations is equal to whatever the number of times we want to perform dilation on our image. By default it's 1, and you can provide, let's say, 2 here, and let's see what is the result now. So I'm going to just run this code again, and now you can see those black dots which we can see here on the masked image are now gradually gone, but still I can see some little dots on the images. The small dots are already gone, right? So now what we can do here is we can increase the size of the rectangle. So this rectangle is applied to our area which have these spots. So we can increase the size of the rectangle, and the bigger the rectangle is, the better the result will be, but there will be a problem which I'm going to show you. So let's run this code, and you can see now all the black dots from our image is gone. So there was a black dot here which you don't see anymore, and there was a black dot here, here, and here, and we don't see these black dots here. but you might also observe that the size of this white area is also increased after we applied the dilation on this masked image. So now this ball and this ball in the result after the dilation is merging here, right? So you can see it's merging because the size of our kernel is big, and when we apply dilation, the pixel element is 1 if at least one pixel under the kernel is 1. That's why the shape of these balls are increasing. So let's see how our next morphological transformation works, which is called erosion, and after that I'm going to explain you how this erosion works and what is erosion. So I'm going to just declare a variable called erosion, and then I'm going to just call a method called cv2.erode. So the method name is erode, and the first argument here is the source, the second argument here is the kernel as we have seen in dilate method, and the third argument is the optional argument, which is the iterations. So for now we just apply one iteration, which is by default also 1, and now we are going to just add this image to our matplotlib window. So I'm going to add the title and the image, and now I will increase the range of the array to 4, and let's say now we want 2 by 2 matrix of these images, right? So let's run this code and let's see what happens. So now you can see 4 results here, and first was the original image, second was the masked image, third was the dilation. So all the spots in the balls which are black are gone using the dilation, but the size was increased, and using the erosion you can see the sides of the ball eroded. So the basic idea of erosion is just like soil erosion. It erodes away the boundary of the foreground object. So when this erosion is applied, the kernel which we have defined slides through all the image, and a pixel in the original image, either 1 or 0, will be considered as 1 only if all the pixels under the kernel is 1. Otherwise it is eroded, and this means this value will be set to 0, which means this will be a black area. So let's increase the number of iterations here. So let's say we want to apply the erosion 2 times on the same image, and I'm going to just run this code once again, and you can see now these balls are eroded more. Let's say we want to increase this to 5 times and then run the code, and you can see now these balls are really small because we have applied this erosion multiple number of times. So let's say this is 1 once again, and let's make this size of our kernel small, 2 by 2 rectangle size, right? So you can see now our result is better because all the spots from these balls are gone, and these balls are not so much eroded. Now there are 2 more morphological transformation methods which are called opening and closing. So we are going to first of all see how opening works. So I'm going to define a variable called opening, and then I will call cv2.morphologyx, okay, and then we will provide the source, which is mask. The second method is the type of morphological operation which we want to perform. So in this we are going to just call cv2 dot, and then we can specify which type of morphological operation we want to perform on the image. So just write morph and then the type of operation. So we want to perform the morph open for the opening, right? And then the third argument here is the kernel which we have defined, and now we are going to just add this opening to our matplotlib window. Let's add this, and then let's do 5 here, and then let's say our matplotlib is going to show these images in 2:3 format. Okay, so let's run this code and let's see what happens. And let me increase the size of this image now, and this is the result of the opening. So what is opening in morphological transformations? So opening is just another name of erosion followed by dilation. So when you perform this opening morphological operation, first of all, erosion is performed on the image, and then the dilation will be performed on the image. So you can see the effect of the erosion followed by the dilation. Still you see some spots here which can go if you can just increase the size of this block. So let's rerun the code. Let's see what happens. So now this image somehow looks better than the older image. So opening is the erosion followed by dilation. Now there is a closing method also, which is just the opposite of opening. In the closing morphological transformation, dilation is performed first on the image and then it is followed by the erosion. So let's see if we get the better result when we perform the closing morphological operations, and the morphological operation here will be close. And run this code, and now you can see the result here. So in closing, as I said, first of all the dilation is applied and then the erosion is applied. In the opening, first of all erosion is applied and then the dilation will be applied. Now there are different type of morphological operations you can apply using this morphology X. So for example, I'm going to just use some of them. So the main morphological operations other than opening and closing is, let's say, morphological gradient. So I'm going to just say mg for morphological gradient, and you just need to change the second argument here. So cv2 morph underscore morphological gradient. So we are going to just call this morph gradient, and it's going to apply the morphological gradient. And then the next is the top hat and the black hat. So there are different morphological techniques you can apply. So I'm going to show you one more and then I will leave you with the other techniques. So th for top hat, and here also the second argument you just need to change it to top hat, right? Otherwise you can see there are so many number of techniques you can apply on your image. So there is gradient, close, open, we have already seen, black hat, cross, dilate, ellipse, erode, hit miss, rect, and then top hat, which is we are going to use right now, right? And then we can just add these two things to our list of titles and list of images. So mg, and then we have th for top hat, and now we have 8 images, so range is increased to 8, and let's say we just want to show them in 2:4 matrix here in the matplotlib window. So you can see this is the result of morphological gradient. So morphological gradient is the difference between the dilation and erosion of an image, and this is the result of top hat. That means it is the difference between the image and the opening of an image. So this is how you can perform some of the morphological operations on the images. Now I will show you one more example. I have a image called j.png, so I'm going to just load this image also, and because this j.png is already a binary image, I don't need to apply this mask here. So instead of this mask, I can just directly use our image variable. So I'm going to just write this, and let's load this image 2 times because we already have defined this mask variable inside our title list and image list. And now I'm going to just run this code. So the original image of this j.png looks like this, and after we applied the dilation, you can see the dilation increases the area of this j. The erosion just erodes away the corners of this j, right? Opening is going to apply the erosion first, followed by the dilation, and closing is going to first of all perform the dilation followed by the erosion. This morphological gradient is going to give you the difference between the dilation and erosion of the image, so it's going to give you this kind of result. And you can see the top hat result here, which is the difference between the input image and the opening of the image. So this is how you can use different type of morphological transformations on your images using OpenCV. I hope you've enjoyed this video, and I will see you in the next video.